All right, for geometry, we are starting Unit 4, Module 4. So this one is Lesson 4.1. It's called Congruent Figures and Their Corresponding Parts. So something that, here I'm going to zoom into this one for a second. Something that you need to know first is that congruent polygons have everything the same. So it's not only angle B that would be congruent to angle F, but also segment AB would be congruent to segment EF. So all of the corresponding side lengths and all of the corresponding angles are congruent if the entire polygon is congruent. So they also need to be listed in the same order. So if we're going from this shorter side A up to side B, when you name segment AB, you need to go from the shorter side E to the taller segment EF. So AB is congruent to EF, and that's why it is in this particular order. So they are corresponding parts, angles, segments, and they need to be in the same order as each other. The other theorem you need to know is the third angles theorem. So basically that means something that we've already known. If B is congruent to E, and if A is congruent to D, then that means automatically we know that angle C is going to also be congruent to angle F because it is called the third angles theorem. Third angles have to be congruent because we know in triangles all three angles, add up to 180 degrees. So if these two are congruent and these two are congruent, then by the third angles theorem, C has to also be congruent to F. Okay, before we talk about corresponding parts, you really need to know your transformations, which transformations again are slides, which is also called a translation, reflections, and rotations. So looking at these two shapes, what transformation was performed to get from this one to this one? I know that it looks like it's also been rotated a little bit, but one of the main things I see is it has been reflected. So this pointier part out here, which is angle L, has flipped, and it's down here with H. So it rotated after it was flipped or reflected. So what are the transformations? I'd say definitely is a reflection. And then it just tilted a little, so it rotated a little. We can say that it was mainly a reflection, but it's a reflection and then a rotation. Now that we know that, we get to name all the corresponding parts. So all the parts means all the angles and all the sides. So let's start with our sides, and let's make sure that we do them in the correct order. So if I were to say side KH, from K to H, that would be congruent to side OL in that specific order. Then let's move on to side, and I'll go ahead and mark that up, KH, OL, and I'm just putting a little one single hash mark showing that that is congruent to that. All right, if I were to put the next side, let's look at JK next. So JK, we'll put the little double hash mark here. If I go from J to K, then that would be corresponding to NO. So in that specific order. So NO. All right, I'm going to have to go down to the next line. Then if I moved on to IJ, side IJ, segment IJ, from here to here, that from I to J would be corresponding to MN in that order. So MN. And if I'm going too fast, just push pause and make sure you understand what I'm saying about the order that you read it from needs to go in the same direction. All right, and then the last side that I haven't named yet is segment HI. So if I were to give from H to I 4 hash marks, then in that order from H to I, it would be from L to M. So we're going to write segment LM is what HI is congruent to. Okay, let's move on to now the angles. So again, the angles, keep in mind it's been reflected and slightly rotated, so be sure you're looking at the correct angles. Let's start with angle H. So which angle is angle H congruent to? I'm going to make one little arc in the corner to mark up H. That would be congruent with angle L. All right, and we only have to name it by its one letter because there aren't multiple angles off of each letter. So this one has a little bit less work for us. Let's move on to angle I. For angle I, go ahead and make two little arcs so that we're labeling it appropriately. I is congruent to angle M. So angle I is congruent to angle M. All right, then let's move on to angle J. Angle J, I'll go ahead and give three arcs. J would be congruent to N. Angle N. All right, and then the last one we have is angle K. So I'm going to give it four arcs. And then I'm going to also match that up with O because angle O would be congruent to angle K. All right, we have named all the sides and all the angles, and therefore it is a congruent shape, a congruent figure, because all of its corresponding side lengths and angles are congruent. All right, let's move on to example 2. It's a rocket. It says the triangles formed on the wings of this rocket are congruent. So they have enlarged these triangles below to show them bigger down here. And it says what transformation was performed. I believe once again we have a reflection. So this one just flipped over to this other one. So this one again is a reflection. And now it wants to know what is the measure of angle D. So if we know that it's a reflection, but we also know that these are congruent parts, then that means 30 would be 30, 75 down here would be 75 down here since it has been reflected. And then knowing this third angles theorem that we just talked about up here, if we have that the other two angles are congruent to each other, then that means that this angle is also congruent to this angle by third angles theorem. And we know that they all add up to 180. So I'm just going to do 180 minus the 75 from this angle minus the 30 from this angle. And when you subtract all of that, it leaves 75 degrees. So that means A has to be 75, but also our question, which is what is D? D also measures 75. Okay, let's turn it over to the back. So now we're going to actually start working our way into real proofs. Are the following triangles congruent? Mark it up. So I see that we have a single hash mark here and here, so these are congruent. I see that we have two arcs here and two arcs down here, so these two angles are congruent. And I see that we have a single arc here and way up here, so E and A are also congruent. So let's see if we can prove the other sides are also and angles congruent. And if so, we'll write an entire congruent statement. So I see the things that are already marked up. Let's see if we can mark up anything else. You should notice that this side has given a number 6, and this side is also given a number 6. So if these are both a distance of 6, we can go ahead and do the double hash marks here and here, showing that these are congruent to each other. All right, and then same thing here with 4 and 4, so we can mark these up. 4 and 4 would also be congruent. So now we have all three sides that are congruent, and we only have two angles that are congruent. So is there a way to show this third angle is congruent? You can know that either based on third angles theorem, or I hope you also remembered these two angles have a special name for each other, and they're called vertical. So these two angles are vertical, which means they are also congruent. So now that we have found that all three sides and all three angles are congruent to each other, we can write a congruent statement. Well, first of all, it's yes, these would be all congruent. And our statement would be triangle ABC, that's this one, and let's be sure we're going in the same order on the other one. So triangle A to B to C is congruent to, in this specific order, triangle that would be E, D, C. E to D to C. So we went from A, which has the single hash mark, to B, which has the double, to C, which has the triple. So you also have to go in that same order when you name the other one. Triangle ABC is congruent to triangle EDC because all parts are congruent, meaning all angles and all sides. Okay, let's move on and do an actual proof where we have two columns. So it's been a while since we've done this. So I'm going to help you review. We're going to put statements on one side and we're going to put the reasons on the other, and we're going to actually work up to triangle proofs. This is an actual triangle proof. So our first statement would be all of the things that are already marked up, all the things that were given as already done. So they're listed over here, so I'm just going to rewrite them. Segment LM is congruent to segment LO. Segment MN is congruent to segment ON. Angle M is congruent to angle O, and angle MLN is congruent to angle OLN. And every single one of those was written up here and was given to us with little markings that they've already been marked up, so that is why the reason is given. Okay, let's move on. We're trying to prove that these two triangles are congruent, which is what it has here. So what else can we show? We can show that out of these two angles that are congruent in these two angles, we can go ahead and show that the third angle in here is also congruent. So let's mark up the 3 hash marks here, and let's write what those are. So angle MNL is congruent, you have to go in the same order, to ONL, angle ONL. And the reason we did that is because of what we've learned today, which is the third angles. I'm just going to abbreviate this for my angles theorem. Theorem I'm going to abbreviate as THM. So third angles theorem. So now we've got all of the angles marked, but do we have all of the sides marked? I see a 1 hash mark and a 2. So what we're missing is this third side. And what you know is that this third side is the same. LN is the same as it is in this triangle as it is LN in this triangle. So LN is congruent to itself, LN. So if LN is congruent to LN, and we can give it its own little 3 hash marks, take a look at this. We learned in an earlier chapter what reason this is. And here's your review. It is called reflexive. If you have the same thing equal to itself or congruent to itself, it is by reflexive definition. Okay, and then we've proved it because look, all 3 angles and all 3 sides are equal. So we have now proven that triangle LMN is congruent to triangle LON, and our reason is that the entire definition of congruent triangles, because by definition, all parts are congruent in 2 triangles that are congruent. So definition of congruent triangles. All right, I would love for you guys to pause the video and try this bottom one on your own, but if you're not ready, I will work this out quickly with you. And if you're pausing the video, go ahead and do that right now. If not, let me help you work through this, and let's see if we can figure this out. So number 1, I'm going to be super lazy right now and just write that because what you should have written is all of the givens because it's given. All right, and it's already marked up for us. So the next thing we would do is we would go ahead and notice that this is a vertical angle. So vertical angles are congruent. So I would write next that ABE, angle ABE, so angle ABE is congruent. You have to go in that same order. So the side that has 3 hash marks has to be first. DBC, angle DBC. And the reason is because vertical angles are congruent theorem. Wow, there's a lot of abbreviations there. So vertical angles are congruent theorem. All right, and I've marked it up so we can see. So we're almost done. We've got all 3 sides and we've got 2 of the 3 angles. So that leaves our third angle, which we learned today is the third angles theorem. So we have angle E is congruent up here, angle C, by the third angles theorem. And now we have all angles and all sides, so therefore we're done. We have now proven that triangle AEB, B, that's supposed to be a B, is congruent to triangle DCB by definition of congruent, I'm struggling today, sorry, triangles, because all the parts of angles and sides are congruent.